Online students, is my voice is loud and clear? Yeah, everyone, could you please confirm? Others also, could you please confirm? Yeah, is my voice is clear, right? Done. So let's start the session, guys. So in the last class, we are discussing about the probability and how to calculate the probability by using the z-score and z-table, right? Now, let's conclude that one. And before moving to further, so in the last class, I asked you to complete this one, right? Assignment as this. Now, in a class, marks of the students forms a normal distribution with a mean of 70 and standard deviation of 10. And what is the marks between 40 to 60, 40 to 50? What is the answer, guys? 0.0231. Okay, 0.02. Okay, something. 0.02 only, right? 021. Huh? 15. Okay, up to 3 decimals is more than enough. Next, 50 to 60. 1359. Okay, 3 decimals. Next, this one. C4 1. Next, this one. So 0.341. Okay, and this one. So this one, right? Next, this one, last 0.021. This one, right? Now, so whatever you have calculated basically, so here if you observe clearly, center value is 70 and right side you have taken 80. What is this 80 means? Mu plus 1 sigma. This is mu basically, followed by 90, followed by 100, which is mu plus 2 sigma and mu plus 3 sigma. And left side 60, which is mu minus 1 sigma, followed by 50, followed by 40. This is mu minus 2 sigma and this is mu minus 3 sigma. Now, whatever you have calculated, right? That is the area between 70 to 80. What are the area is there between 70 to 80? That is from here to here. What is the area means? 34%. If I have to write in terms of 34 percentage, percentage means just multiplying into 100. Every value, if you multiply into 100, you will get in terms of percentage. So I'm just calculating 34%. From 80 to 90, how much percent? It is 13.5%. And from here to here, it is 2%. That is 2.1. You are going to get 2.1%. Now, here if you observe clearly, okay, for any normal distribution data, not only for this example, for any normal distribution data, we will get automatically by default between mu and plus 1 sigma. What is the area means? 34%. For any example, consider any example of your choice. What are the mean value to 1 sigma? That value will be always 0.34 only. For example, if you consider this number, okay, now see here mean is 70, standard deviation of 5, mu plus 1 sigma, that is 70 to 75. What is the value? 34. Why? Because this is mu plus 1 sigma. The mean to mean plus 1 sigma. What is the distance? 0.34. That is the probability. Now, if it is minus mu minus 1 sigma to mu, what is the value? 0.34. In this example also, in this example, mean of 60 with a standard deviation of 10. And I asked to calculate 60 to 70. What is the 60 to 70 means? Mu to mu plus 1 sigma, it is 0.34. Mu minus 1 sigma to mu, 0.34. So, mu to mu plus 1 sigma, right side it is 34%, left side it is 34% area. So, 34% or 0.34. If you are checking from the probability point of view, 0.34. So every time it is fixed. That is the reason I shown you 3 examples. So last class we have completed these 2 in the class. While at the end we are doing this one only. And also I ask you to do this one for you. The reason of doing this one is here we are having a concept called as mu with mu plus 1 sigma, always it is 34%. Mu minus 1 sigma to mu, it is always 34% because it is a symmetrical distribution. For normal distribution data, right side how much distance is there, left side also same amount of distance will be there. Distribution will be there. So now what is the, for example, mean value is 70, standard deviation is 10. What is the probability of x greater than 70? What is the value of x greater than 70? Means it is 50. So right side 50% will be there. Left side 50% will be there. It is fixed. Total area is 100%. Percent is 100%. Value wise, it is called as 1. 90%. What is the meaning of 90% value wise? 0.9. This is value wise. This is percentage wise. Okay. Total area. What is the total area? 100% or value wise total area is equal to 1. Value wise 1, percentage wise 100%. Point is clear? Both are not same. This is value. If I am writing here 0.9, 0.9 means value wise. Don't think 0.9%. 0.9 is the value, 90% is the. So whenever you want to represent percentage, 100%, we have to use the percentage side. Now, if I don't write the percentage and if I write 90, the meaning is what? Value or percentage? It is considered as value. Unless you write side percentage symbol, then only it will be considered as percentage. When it is percentage, automatically it has to be percentage means 1 by 100. The meaning of percentage symbol is 1 by 100. Now here 34% is there now. What is the meaning of percentage symbol? 1 by 100. 1 by 100 means 34 divided by 100, which is 0.34. So mu to mu plus 1 sigma 0.34. Mu minus 1 sigma to mu also 0.34. And here what are the value from mu plus 1 sigma to this one? 13.5. So the same thing you got here. 13.5. Okay. So if you observe this one, mu, what is the mu? Here in this case, mu is 70. Mu plus 1 sigma, that is 80. What is it? What is the probability between 70 to 80 means? What is the answer? 34, which you calculated from the Z table. Now, what mu plus 2 sigma? From here to here, what is the probability? From 80 to 90? From the Z table, you calculated 0.135. And which is the standard. Every time it is going to be the 13.5 only, 13.5%, which is also called as 0.135 value wise. It is always fixed. Now, this concept is called as 68, 95, 99.7% rule. This concept name is called as 68, 95, 99.7% rule. Point is clear, guys? Now, what is this 68, 95, 99.7% rule means? The probability between mu minus 1 sigma to mu plus 1 sigma, the probability is going to be 0.68, or which is also equal to 68% area. Area wise 68%, probability is equal to 0.68. So probability we can't say 68%. Probability value always lies between 0 to 1. Probability, when they ask the question, what is the area? You tell in terms of like this. When they ask the question, what is the probability? You tell like this. That is the standard notations. Basically, both are same. Okay. Now, what is the probability or area between minus 2 sigma to, that is mu minus 2 sigma to mu plus 2 sigma? Means it is equal to 95% overall from here to here. If you combine everything, that is from this one to this one, if you combine everything, you are going to have the 95. Right? Now, what is the probability of mu minus 3 sigma to plus 3 sigma? Means the area covered between minus 3 sigma to area covered plus 3 sigma is 99.7%. It is covered. So it is called as 68, 99, 95, 99.7% rule. Now almost 99.7% of the data is covered. Sir, what about the 4 sigma, 5 sigma, sir? More than 3 sigma, anything is almost close to 99.99. There will be no much difference. Okay. So almost 99.7% of the data we are covering, means literally 100% of the data will be covered between plus or minus 3 sigma only. Sometimes whichever the value is crossing more than plus 3 sigma, that value we consider as outliers also. Okay, they are considered as outliers. Right? Now, so see here, what is the probability? See, okay, we gathered the last mock test conducted at Naresh IT and found it to be a normal distribution with a mean of 70 and standard deviation of 10. Mean of 70 with a standard deviation of 10. What is the probability of students having marks below 70? How many students below 70 means 50% of the people below 70, 50% of the people above 70, because mu is center, symmetrical distribution. Now, same logic can be applied on the skewed data? No, because skewed data, left side how much is there, right side may not be the same. But in the skewed data or normal distribution, one concept remains same. What is that means? Sum of the probabilities will be 1. Whether it is left skewed data, whether it is right skewed data, whether it is symmetrical distribution also, sum will be the same. But only difference is in the right skewed distribution, right side you may have the less amount of probability, left side you may have the more amount of probability. It is not symmetrical now. Point is clear, guys. Since it is not symmetrical, one side you will have more than 50%, other side you will have less than 50%, but total will be 1 only. Total cannot be more than that. For symmetrical distribution, exactly on the left side how much is there, right side also same will be there. Right? So, sir, when we are having this much of simple rule, then actually why you ask to us to calculate all these things, sir, means very simple. In this rule, for example, for this question, this is 70, mu plus 1 sigma. According to the question, what is the mu plus 1 sigma means 80, 90, 100. What is the probability between 70 to 80 means 34%. What is the probability between 70 to 90 means a combination of these two, which is nothing but 47.5. What is the probability from 60 to 70 means 34. What is the probability from 60 to 80 means 68. What is the probability from 60 to 90 means 60 to 90? What is the probability? 68 plus 13.5, which is 81.5. So like this, easily we can calculate. But why I have explained for you all these things then means 70, 80, 90, okay. For example, I want to calculate between the area 75 to 85. Now, Using this rule, can you calculate? Is that possible, miss? No. Since it is not possible with other values, yesterday whatever you have done, right? That can be done from any value to any value. But this can be done only with a mu to mu plus 1 sigma value only. For example, I want from 70 to 76. How to calculate the probability between 70 to 76 using this rule? Is that possible? No. Using the z-score and z-table? Yes. Is the point is clear? Everyone? Yes or no? Clear, guys? So you can calculate the probability when the data was not given with two options. When the data was given, simple, one concept only. Probability of number of records satisfy your requirement divided by total number of records. When the data was given. When the data was not given, two options are there. What are the two options? One is 68, 95, 99.7% rule. Second one is z-scores and z-tables. Clear, guys? Now, let's calculate the same. Yesterday, whatever you have done, right? That example. So now I want to calculate. Okay. Now I want to calculate the probability in the Python. Same whatever you have done. Now, how to calculate the probability in Python means very simple. First, let's take an example. What you have calculated yesterday, the same example. First, 60 to 70. This is my requirement. What is the probability of 60 to 70? Okay, probability of 60 to 70. What is the probability of 60 to 70 means? First, what I have to do? First, I have to calculate the probability of x less than 70 minus probability of x less than 60. Now, how to calculate the probability of x less than 70 means? First, you have to calculate the z-score of 70. How to calculate z-score of 70? G70. What are the G70? That is nothing but z-score of 70. How to calculate? 70 minus its mean value. What are the mean values there? Divide by standard deviation. So first you are going to calculate this one. And what is the Z of 70 you got? Open your notes, calculation 0. Now at 0, what is the probability? I mean, in the Z table, exactly at the 0, what is the value? 0.5. Now the same thing how I'm going to calculate here means from stats.norm. Okay, from SciPy, I'm going to import the stats. Within the stats, norm.cdf. What is meant by CDF? CDF means cumulative density function. What is meant by cumulative density function? Cumulative probability. So, see guys, I'm calculating from less than 70. Less than 70 means from where? Starting to 70. Starting to 70. That minimum value to 70 is called as what? Cumulative. Starting to 60, what it is called as? Cumulative. Starting to 90, what it is called as? Cumulative. So what you are calculating is basically cumulative probability. Right? Now what are the cumulative probability you are having? Here I am writing the 0. For 0, if z value of 0, what is the probability value? 0.5. So within the cumulate here, what you have to write? Z value you have to write. What it will give? Probability. Now let us cross check that Z table. Let us open the Z table once. In the Z table, now let's take one example so that we can cross check ourselves. For Z table, Z of within the Z table, I want Z value. Okay, what are the Z value is there? Is equal to minus 2.15. For this, what is the corresponding probability? What is the answer, guys? For minus 2.15, anyone? What is the answer? So 2.1 means this one. In this line, 0.5. What is the answer? 0.158. This is the value, right? Everyone is okay? 0.0158. Now let us cross check in the Python. As per the Python, what is the value it is going to give? Let's cross check in the Python. In the Python, here what you have to provide? Z-score. What is the Z-score I told you? Minus 2.15. For minus 2.15, what is the answer it has to give? 0.0158. Can you see 0.015? It is up to 4 decimals. If you make a round figure up to 4 decimals, what is the value you are going to get, miss? 0. So I'm writing here round number, round figure. Up to how many decimals? 4 decimals. Is the point is clear? So Z table manually you are opening. In the Python, what we have to use the Z table? What is the code for the Z table in the Python? stats.norm.cdf is the function. Inside this, what you have to write? Z-score. See, here I have written clearly the note. Can you see the note? What is the note? To calculate the probability using the Z-score, what is the syntax? stats.norm.cdf of Z-score. When you provide the Z-score as input, what is the output? Probability is the output. Now Z-score I have given 0.59. What is the output, guys? When I give the 0.59, now tell me here for 0.59, what is the output? 0.59. 0.5 is this one. 0.9 is this one. What is the value? 0.7224. Let us cross check. Same answer. Clear now? So whatever in the Z table in the Python, it is equal to stats.norm. Now, see guys, again I'm opening the Z table. Now this time I will tell you the probability. You tell me the Z score. I'll tell you the probability. Some number I will give you. The probability is 0.877. What this number? This is Z score. This is probability. What I have given to you? Probability. What I am asking for you? Z score. Tell me wherever 0.877 is located. 0.777, 8, 82, 85, 87, 877. Here it is available. What is this value? 1.16. So 1.16. Is that okay, everyone? So when I have given you the probability, can you calculate Z-score? Yes. When I give the Z-score, can you calculate probability? That is also possible. Both of them. If I give this one, that one. If I give that one, this one. So now when I provide the probability and I want the Z-score as the output, what is the function we have to use in the Python means PPF. In the PPF, what you have to provide? Inside that, probability as the input. I'm providing the probability 0.877. When I provide the 0.877, what is the output now? 1.16. Is that clear? This is the Z value. So within the stats.norm.ppf, inside that what you have to provide? Probability. In the CDF, what you have to provide? Z-score. If Z-score is the input, what is the output? Probability. If probability is the input, what is the output? Z-score. That was given, this will be calculated. This was given, that will be calculated. Clear, guys? Yes or no? As one of the student is asking to repeat. Sapna, just okay. In the CD, if you give the Z-score, some value, You provide this one. This one is you provide. Output, what is the output you are going to get means probability. So that is, and if you provide probability as the input, you provided probability, then what is the output? Is z-score. Right? Now, in the z table, one more time guys, in the z table, now I'm providing for you z value as 0.62. For 0.62, z value I have provided, I'm asking probability. Similarly, probability was given as 0.9099. This is the probability. I'm asking what is the z-score. For two questions, tell me the answers. For the question number 1, z was given and I'm asking probability. What is the answer? 0.62. What is the answer? 0.62. This is the one. Is that okay? First, this is everyone is okay? 0.732. Now tell me what is the function I have to use? Now whatever you have done for this, what is the function? Stats, within the stats dot norm. Norm means normal distribution. CDF of 0.62. CDF, cumulative density. Density means nothing but probability. Cumulative density function. Density, area, probability. All of them are same. Three of them are same. Clear? Density, area, probability. In the interview, they ask what is the density covered means area covered or probability. Both are same. Now, this is first question. Question 1 is completed. Now, question 2. What is question 2? 0.99. What is the z-score? What is the z-score at 0.9099? What is the z-score value? So 0.99 here, that is nothing but 1.34. Now p value was given. You should not see 0.9 here, not this one. I have given what? P value. P means internal value I have provided. This one I have provided. Corresponding z-score you have to tell me. What is the value? 1.34. 1.34. Okay. 1 point, not 3. 1.3 means 0.9032 only now. 9099. I'm asking 9099. This one. This one. Is the point is clear? It is 1.34. For this, what is the function we have to use? Stats dot norm dot ppf. What is ppf? Means point probability function. Point probability function. Point means for a given z-score, probability. Point means z value. Point for probability function. Now inside this, what you are going to provide? 9099. Then what is the output you are going to get? 1.34. Let's cross check. If I give this one, what is the output I will get? If I give this one, what is the output I will get in the Python? So just here I am writing the inside this 0.62. First I am writing 0.62. What is the number I have got? 0.7323. Same answer. Now, in the PPF function, I'm providing the 0.9099. It has to give 1.34. Right? Now, next one is called as round function. Now, what is meant by round function? This is the function. In this function, we have to provide two arguments. What are the two arguments? Means one is the value. You provide some value. And up to how many digits you want the round figure. Number of digits. Number of digits. Up to how much digits you want to make the round figure. For example, I want this one. This number. What are the round is there? Round of this number. This entire number. Up to how many digits I want? Comma. How many digits I want? Miss, I want up to 4 decimals. I want up to 4 decimals. I'm writing comma 4. For example, I want 2 decimals. I'll write 2. If I want up to 1 decimal, 1. How many number of decimals you want? You have to write here. Value along with the number of decimals. Okay, is the point is clear? Right? Whoever has asked the question round figure. Round. Is that clear? Ishwar Satish. Done. So this entire thing, copy, and instead of this value, I'm pasting this one. Basically, this one only. This output, first it will calculate the output because inner bracket will be executed first. Inner bracket will be executed first. So that will be executed followed by, you'll get the 4 digits. Basically, inner bracket will be executed first. Within the function, one more function. Within the function, one more function. Which function will be executed? Int of, float of 24. Which one will be executed first? For example, if I write here bool of float of 24, which one will be executed first? Float of 24 will be executed first. And what are the float of 24 is that? That is 24.4, sorry, 24.0. For that, bool will be applied. Same logic. First, this will be applied. And it will calculate the value. This entire value will be calculated here. And for that, it will apply the round function on that. Simple. When you are having the multiple functions, inner function will be executed first. Right? Now, next, let's move on to this. Now, here you are having in terms of probability, how to calculate the probability of a continuous variable means option 1. When they have given the data set, directly you are going to calculate the probability in this way. Option 2, when the data set was not given, in that case, you are going to apply either 68, 95, 95.7 rule or by using the z-score. But both options will work only on the normal distributed data. First, the data should be normally distributed. And how to check whether the data was normal distributed? Already we have completed. 4 options are there. What are the 4 options? Means skewness, mean and median, histogram, KD plot. After checking the data is normally distributed, then only we can apply these logics. If the, so for example, data is not normally distributed, then first you have to convert the norm, which are the data, skew data is there. First you have to convert. After converting, then you have to do. Sir, how to convert? That is next class. Okay, we'll discuss one by one. Conversion part is next. Sir, without conversion, then how we can calculate all these things? Means now these questions only will be asked in the certifications. For example, you are not taking any kind of certification related to data analyst. Then these questions are not required for you. Z table is not required, Z score is not required, this one is not required, all these things are not required. I no need to open the Z table only for you. Why I have discussed that one? Because you are going to take the certification. Manually, you have to write everything. Why we are discussing calculation of variance, calculation of standard deviation, calculation of everything manually? Why you are doing that one? How to calculate the percentage, how to calculate this one? Why we are doing all the things manually? In the real time, we will do the manual. That too 10,000 records will be given in the real life. For that data, we will do manually calculating the mean value, calculating the median value. No, just why you are discussing everything manually also. First, I can explain what is mean, and directly I can show the Python code only now. Again, what is median? Python code. What is meant by variance? Python code. Why I have to do the manual calculation? Meaning and Python code. Meaning and Python code is sufficient now. Why we have to do? Two reasons. Reason number one, any function, we are using that function means for every function in the backend, some code was written. We have to understand what would be. Okay. Next, most importantly, manual calculations will help you for certifications. Okay. In the certifications, they are not going to give the Python codes. Is the points are clear, guys? So what is Z-score means? Z-score is nothing but here converting the value to x minus mu divided by sigma is called as Z-score. Single value are converting or multiple values you are converting. Now, if you are converting a single value, for example, if you take a single value 60, this is a single value. There is no other values. Only 60 if you are converting, that is x minus mu divided by sigma. What are the sigma is there? X minus mu divided by sigma, right? That is standard deviation. If you are converting a single value, now when you are converting the 60 first value, if you take first value, and if you take second value, and if you take third value, and if you take 90 fourth value, like this, each and every value if you convert, how in the given data, entire data, what are the values are there? If you convert each and every value to corresponding Z-score, it is called as standardization. In the last class, I have already told you this. What is standardization? Means converting each and every value to corresponding Z-score is called as standardization. Now, here, this is a normal distributed data with the mean of 70, 80, 90, 100. Okay, 60, 50, 40. Now for this data, what is the mean and what is the standard deviation, guys? What is the mean and what is the standard deviation? Mu is equal to 70. How you concluded? Exactly in the center, what number is that? That one. Here in the peak level, what are the number is that? That is the mean. And the difference between these two values is called as sigma, which is 10. So in the diagram, if they don't give the mu and 70 also, simply they have given the diagram like this also, still we have to understand. They will not give the mean and standard deviation. Simply they will give the diagram and they'll ask, calculate the area between 70 to 90. We only have to understand mu is equal to this one, standard deviation is equal to this much. Now, if you convert every value to corresponding Z-score. Now, what is the Z-score of 70, guys? What is the Z-score of 70? What is the Z-score of 70? 0. Z-score of 70. 70 minus 70 divided by 10 only, na? 70 minus 70 is 0. 0 by 10 is 0. What is the Z-score of 80? Automatically it is going to be 1. Followed by 2. Followed by 3. Minus 1. Minus 2. Minus 3. 40 will be converted to minus 3. 50 will be converted to minus 2. 60 will be converted to 1. Minus 1. 70 to 0. 80 to 1. 90 will be converted as 2. 100 will be converted as 3. Okay. So when you are converting a normal distribution data to corresponding z-score, this distribution is called as standard normal distribution. This distribution is called as standard normal distribution. When you convert a normal distribution data, to corresponding z-score, when a normal distribution data converted to z-score, it will be converted as standard normal distribution. Sir, if I convert a skewed data, don't apply the logics on the skewed data. Everything is only normal distributed data. Okay. Normal distributed data, when you convert to corresponding z-scores, you are going to get like this. For always standard normal distribution, every time it will have mu is equal to 0, sigma is equal to 1, fix. Sir, this example is like that, sir. How every example will be like that? Let's give a try. Now, in this case, let's go with this example. For this example, mean is 70, standard deviation is 5. Let us draw the first normal distribution. 70, 75, 80, 85. This side, 65, 60, 55. Okay. For this question, this is normal distribution. Everyone, this is the question. For this is the normal distribution. Now convert every value to corresponding z-score. Convert. What happens to 70 now? 70 minus 70 divided by 5. What is the value? 0. 75. 75 minus what? Now 75 minus 70 divided by what? Divided by 5. So which is 5 by 5? Again, 1 only, na? Simple, guys. X value, z value. If x value is equal to mu value, corresponding z value will become the mu minus mu divided by sigma, which is 0. If x value is mu plus 1 sigma, then z value will become mu plus 1 sigma minus mu divided by sigma. Mu cancels. That is 1 sigma by sigma. Sigma cancels 1. When mu plus 2 sigma, what are the mu plus 2 sigma values there? Mu plus 2 sigma minus mu divided by sigma. That is mu cancels 2 sigma divided by sigma. Sigma cancels 2. So that is the reason here wherever you see, if you write here 70, 75, 80. 70 is what? Mu value. What is this value? Mu plus 1 sigma. What is this? Mu plus 2 sigma. When you convert this one to corresponding z-scores, what happens? Mu value will be converted to 0. Mu plus sigma value will be converted as what? 1. Mu plus 2 sigma will be converted as 2. Automatically. Is the point is clear? Now the interview question is like this, or certification question is like this. For standard normal distribution, what is the mean value and sigma value? What is the mean and sigma value for standard normal distribution? Miss 0 and 1. That is the one of the most important certification question. More number of times it is repeated in the statistics. Is the points are clear, guys? Everyone? Now, this question is one more most important question. What is that question? Question is simple. The question is like this. What is the question is? Let's take an example. Yeah, this is the example, guys. In a class, marks of a student forms a normal distribution with mean of 70 and standard deviation of 10. Please write this question. Already we have written yesterday, no sir. One more time you write, please. I'll tell you the reason. In a class, marks of a student forms a normal distribution with mean of 70 and standard deviation of 10. Right, guys? Completed? Now, okay. Marks of students forms a normal distribution with mean of 70 and standard deviation of 10. Now draw the normal distribution diagram. Draw. For this question, normal distribution diagram. Completed? Diagram. Okay. Now question number 1. What is the probability of x less than 70? What is the answer? Answer. How much is the probability x less than 70? Less than 70, how much area is there? Huh? Sorry. What is the answer? Loud, please. 0.5, which is 50%. What is the second question? Question number 2. What is the probability of x greater than 70? And this is also equal to 0.5. Okay. These two questions are okay. This is my question, favorite question, interview question. And assume this question was asked in the interview, means 100% you will get a very good package. 100% blindly. What is the question is? Very simple question. What is the probability of x equal to 70? What is the probability of x exactly equal to 70? Let's see how many of you will answer. What is the answer? Answer. What you told? 0. 0. 0 point, I understood. What is that next number? 1 8. 0 0.0. 0 0.0 means 0 only, right? 0 0.01. 0 0.01. Others? 1. Exactly probability of this one. Okay. One student gives the answer as option A. One student has given option B, only 1. Option C. Still, any answers? I don't want anything. Just I asked, this is the question and this is the question. Answer. Just answer. 0 0.003. Okay. 0.03. Still. Boolean value. False. False. Boolean value false. Okay. Next. Next. Still. You are saying something, right? Earlier. 0.01. For your side is 0.01. You told something? Last. Last bench, last. 0. Only 0. Okay. Done? Still? Still any numbers? Yeah. So the person who told 0.01, could you please raise the hand? This is the right answer. Who has told? Please raise the hand. Tell me the reason, please. How? This is the right answer. Assuming. Total number of students are 100 are there. In that one student, this one. On what criteria? How you calculated? 1 by 100. How? Why 1 by 100? This is one number. Okay, 1 by 100 by half rand rise na that student. Why? Okay. Student who told this one? This is the right answer. Who told this one? Reason? Take. This is the right answer basically. Who told this one? Probabilities are equal to 1. So here I asked the sum of the probabilities. Basically, this is the correct answer. Who told? Some student has told this one. Yeah. Reason? Okay. 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 Now, this is the right answer. Who told? If I say right answer, you'll create the answer, na? You'll think that you have done correctly and you'll say that. If I say wrong, miss, you'll not even speak also. You have to speak, miss, I have to say that is right. Then you'll speak. Why it is false? Conditional? X is equal to 70. So conditional operator. No, I'm asking, but being as X is equal to 70. What is the probability of marks is equal to exactly 70? Marks are equal to 70. Now, 0. This is the right answer. Who told? Reason? You are assuming? X also 70. Okay. One more person. One more person. Who told E as 0? I mean, reason. Sorry, I can't see you. Reason? No reason. Casually. Okay. To be more precise, this is the exact answer. Real answer is this one only. 0. The reason behind this is very simple reason. So probability of a single value, it is not in the center or nothing. Not only this one, any number 72. What is the probability of X is equal to 72 also? 0. What is the probability of 73 also? 0. Probability of 74 also? 0. For any single number, the value is 0. Why? Means point is very simple. That is one of the number divided by, we don't know how many numbers are there. We don't know what is the divide by how many numbers are there, which is infinite. So answer is 0. So what would be the temperature tomorrow in Hyderabad? Probability exactly 25 degree. Sorry, 26 degrees. 25 or 20, what are the number? 26 degrees. What is the probability tomorrow? What is the probability? What is the probability of tomorrow temperature will be exactly 26? Exactly 26. Exactly. Means it is going to be one number out of tomorrow. How many numbers are possible? 26 is possible. 26.1 is possible. 26.12 is possible. 26.14 is possible. 27 possible. 27.12 is possible. 27.84 is possible. Like that, infinite numbers are there. Whenever you are asking a single value, the probability of a single value is 0. Unless data was given. When data was not given, the probability of a single value is always 0. The probability is always 0. Single value. Now, if you observe in the diagram, okay, here we are calculating from mu to mu plus 1 sigma with the interval, or not only this one. What are the examples you have done till now? You calculated from 70 to 76 or less than 70. Let's take less than 70 also. That is nothing but 0 to 70. Less than 70 means minimum value to 70. So till now, whatever you have calculated, everything is basically interval only. When you calculated less than 70, or if you calculated x less than 80 also, it is basically interval. X is less than 80 means minimum to 80. That is the meaning. Cumulative you have done from minimum to 80. If you are asking probability x is greater than 80 also, basically you are calculating for the interval 80 to maximum. So always you are calculating everything to the interval only. Till now we have never calculated the probability of a single value. The probability of any single value is 0. So for example, if I have given a histogram like this, from 30 to 40, 5 students are there. 40 to 50, 4 students are there. 50 to 60, 2 students are there. If I are given like this, how many students are there with 45 marks? How many students are there with 45 marks? You don't know, na? 40 to 50 I have given 4. In that 41 might be there, 42 might be there, 47 might be there, 48 might be there. Who 4 students? You know? Then the probability will be equal to 0. Is that clear? Probability of a single value is always 0. This is the right answer. But by default, since I told this one is right answer, this one is right answer, these students, if I say right answer also, they have laughed. But really it is right answer. Okay, it is not in the middle value, or it is not assuming the value as x is equal to 70, nothing. For any value. So, for example, you are having the temperature. I have given the temperatures of last 1 month temperature, or not even 1 month, 1 week. 1 week temperatures I have provided for you. 1, 2, 3, 4, 5, 6, 7. 7 days temperature I have provided. And based on last 1 week temperature, this is last 1 week. Based on 7 days temperature, I asked what would be the temperature tomorrow. And you have told that, sir, last 1 week temperature average I have got 26.5, sir. So tomorrow it would be 26.5. This a general person will say. But statistician should not say. Why? Because the probability of exactly being 26.5 will be 0. Statistician always has to predict with a interval. They should not say with a single value. Prediction never should be done with a single value. Now, if I show you one car, okay, some car. Now, if I say that this is a used car, not new car, used car. Used car means second-hand car. Now, second-hand car, if I have shown you, and I have told you some features about the car. This car has this one, this one, this one, about the car. Year of, this is a 2024 model only, just a 3 months old car. And in this only 100 kilometers was driven. Something, I have given all the details. And I asked you to calculate what would be the value. I asked you to estimate what is the value. New car is 10 lakhs. You are assuming, okay, this since it is a new car is 10 lakhs and it is a just 2 months old, you are going to estimate as 8 lakhs or something. Assume some number, random number you are saying. Now, to be more simplified, what would be the cost of this building? What are the building we are staying as of now? What is the cost? Tell some number randomly, not a problem. You are not good at real estate, I'm also not good at that one. Just tell me some number. 10 crores. One student is saying 10 crores. Whether it is true or false, let's keep aside. What is the probability of being 10 crores means 0. Now, we should never say with a single number. General normal persons will say with a single number. Statisticians should not say with a single number. Statisticians or data analyst or data scientist, you should not say with a single number. Always you have to say with a interval, 9 crores to 10 crores. or 9 to 11 crores. So that what are the number you are interested, it should be the part of that one. This is having some probability. Probability is only associated with the interval. Probability is not associated with a single value. Anything you take, even 9.9 crore to 10.4, 10.01 crore only you take. But interval. Okay. This interval only we call it as next concept, central limit theorem. From where they got this concept means for continuous variable, the probability of a single value is 0. Okay. Since probability cannot be calculated for a single value, we have to take a interval, and that is nothing but point estimate plus or minus standard error. So as I have told you, if I have given you the last 1 week temperature, last 1 week temperature was given to you, what would be the tomorrow's temperature? You are going to say by default mean, which is a single value, which called it as point estimate, single value. Point means single value. Okay. So you are estimating a single value, but you should never estimate a single value. That value, for example, average is 28 degrees. Instead of saying with a single value, you have to add some error, plus or minus 1, something, some error. Okay. And then you are going to get the 28 minus 1 to 28 plus 1, which is 27 to 29. Sir, what is the advantage like this, sir? This is having some probability. The probability of this one is 0. This is having some probability. Maybe 5% or 10% or 15%, at least something will be there. Something probability is there. For this, completely it is 0. Is the point is clear? Now, so this error is there now, plus or minus error. That error only we call it as standard error. Okay, point estimate plus or minus standard error. So this is the formula. So x bar minus sigma by square root of n2, x bar plus sigma by square root of n. Always we have to do the estimation with a error. We should not go with a single value. For discrete variable, single value only. There it is not interval. Discrete variable, single value. Continuous variable, interval. Points are clear? Everyone? Yes or no? This is called as central limit theorem. What is meant by central limit? Central limit means nothing but, okay, central limit means nothing but, so your center value only will be there. For your center value, plus or minus, you are adding the error. Basically, you are focusing on this one only. So for your interval, what is the again center value? For your interval, what is the center value? Center value is nothing but what you are estimating. But for that center value, left side you are adding something, right side you are adding something. Is the point is clear, everyone? Okay, everyone is clear or not clear? Done. So this is called as central limit theorem. The next concept is called as confidence interval. Okay. This is called as confidence interval, which we'll discuss next class. Okay. As of now, we are not going to discuss. Just ignore this one as of now. We'll complete in the next class. We'll go along with this inferential statistics. Both are connected to each other. Now, till now, whatever we have done, everything was calculated on a single column. Did we included any measure with by including two columns? Check, cross check once. Yesterday we have made the list of measures. Na? Mean was calculated on a single column or multiple columns? For a single column, mean separately. Median is calculated for a single column or multiple columns at a time. By including means while calculating the mean, in that have you included other column value? For example, what is the median of this one? What is the average of this one? Is average is dependent on if, for example, this one is there. Whether this one is dependent on this one. For example, instead of 10, 12 is there. Any X bar will change. Median will change. Median will change. Minimum value will change. For example, here 8, 19 is there. Whether these values will change? No. So everything whatever we have calculated till now on a single column only. Okay. Minimum value of a single column separately. Maximum value of a single column separately. Range also. Variance also. Standard deviation also. Percentile, quartiles, upper limit, probability. Anything on a single column separately. First we have taken a single column. For that we have applied the histogram. First we have taken a single column. For that we applied the KD plot. For a single column we have taken separately and we calculated the percentiles, quartiles, and from that upper limit and lower limit and box plot. Till now whatever we have done, everything is on a single column. We have not included two columns at a time. So all these measures, till now what are the measures are calculated? Every measure is called as univariate measures. So till now whatever we have calculated, all of them are called as univariate. Variate means variable. So uni means one variable measures. Okay. Till now whatever we have done. So univariate measures. Okay. All of them are called as univariate measures. And what are the plots we have discussed till now? All of them are called as univariate plots. What are the plots we have completed? First started with the box plot. After that, we have seen the count plot, which was applied on a discrete variable. After that, histogram. After that, KD plot. All these plots are done on a single column. None of them are included with the multiple two columns. Is the point is clear, everyone? Yes or no? Right? Now, here we are moving on to the next concept called as bivariate measures. Bivariate measures means by considering two columns at a time. These can be calculated by considering two columns at a time. With a single column, we cannot calculate these measures. What are those measures are called as covariance and correlation. Covariance and correlation. These are the two measures which are applied by using the two columns at a time. Bivariate measures. What are the bivariate measures? Covariance and correlation. Done? Now, so what are the covariance and correlation you are having? Bivariate measures. These bivariate measures we are going to have in terms of like this. The first one is covariance. Let's start with the covariance. So in order to calculate the covariance, we require the two columns, both X and Y. First one, second one. both x and y. Two columns are required, x column and y column. Okay. Now, what are the two columns? You are having x and y columns. Now, we are going to calculate variance of x. What is variance of x? Means single column separately. Variance of y, single column separately. Now, we are going to use both the columns at a time and we are going to calculate the covariance. Now, let us see. Now, here I am going to take some numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or instead of this one, let's go with one more. So, okay, done. Okay, 16, 17, 8, 9, 10. This is the one. Now, this is the data. Everyone, please take that data in your notes. X, Y, 1, 2, 3, 4, 5, 16, 7, 8, 9, 10. Sir, why you are not choosing the 6 means? The reason is very simple. You'll understand after doing the calculation and formula. Okay. Now, first, I'm going to calculate the covariance of x comma x. What is the covariance formula? Means covariance is equal to x minus first column minus its mean into second column into its mean minus mean. That is sigma of divided by n minus 1. Sample covariance was given by formula x minus x bar into y minus y bar divided by n minus 1. Now, if I take only x column, two times I am taking the x column. That is, first I am going to take x minus x bar. Again, I am going to multiply with the x minus x bar only. That is nothing but x minus x bar whole square sigma by n minus 1. What is this is called as? What is the formula? What is the it is called as variance of x. It is called as variance. See here, just observe guys. Don't write simultaneously till the entire calculation is completed. First, I'm going to calculate the x bar. What is the x bar? Means 3. I'm going to calculate x minus x bar. That is 1 minus 3 minus 2, 2 minus 3 minus 1, 3 minus 3 0, 4 minus 3 1, 5 minus 3 2. Everyone is okay? Next, x minus x bar into again x minus x bar. 2 times I'm multiplying. Same thing. That is minus 2 into minus 2. 4, 1, 0, 1, 4. Okay. Sigma of x minus x bar into same column x minus x bar. What is the total sum? 10. 4 plus 1, 5, 0, 5 plus 1, 6 plus 4, 10. Next, I'm going to calculate y minus y bar. For that, what I required? Y bar value. What is the y bar value? 16 plus 7, 23 plus 8, 31 plus 9. What is plus 9? 40 plus 10, 50. 50 divided by 5. What is the value? 10. Now, 16 minus 10, 6. 17 minus 10, minus 3. 8 minus 10, minus 2. 9 minus 10, minus 1. 10 minus 10, 0. Okay? Everyone is clear with y minus y bar? Now, y minus y bar into, again I'm going to multiply with y minus y bar only. That is 6 into 6, 36, 9, 4, 1, 0. Total of y minus y bar into y minus y bar. What is the value? 45, 49, 50. Next, x minus x bar into y minus y bar. What is the value? That is 4 into, sorry, not this one, minus 2 into 6. Minus 2 into 6, what is the value? Minus 12. Minus 1 into minus 3, plus 3. 0 into minus 2, 0. 1 into minus 1, minus 1. Okay. Next, 2 into 0, 0. Right? Now, what is the total of this one? That is sigma of x minus x bar into y minus y bar. What is the total? Minus 15, sorry, minus 9, minus 10. Total is minus 10. Right? Now, first, I'm going to take the covariance of x comma x. What is meant by covariance of x comma x? Means x minus x bar into again x minus x bar. Sigma of x minus x bar into x minus x bar divided by n minus 1, which is nothing but 10 divided by, how many values are there total? N is equal to 5. Divide by with what value I have to do? 5 minus 1, which is 4. What is the value? 2.5. Now, covariance of x comma y. What is x comma y? That is sigma of x minus x bar into, what is the next value I have to multiply? Y minus y bar divided by n minus 1. That is minus 10 by 4, which is minus 2.5. Next, sigma of, sorry, covariance of x comma y. Completed now. Now y comma x. What is y comma x? Means x minus x, y minus y bar should be multiplied with the x minus x bar. Now y minus y bar into x minus x bar or x minus x bar into y minus y bar, both are same only, right? So minus, finally these 5 values will be the same. Sum also will be the same only, na? Divide by n minus 1. That is nothing but minus 2.5. Is there any change? These both are same. Covariance of x comma y or covariance of y comma x is both are same. Next, covariance of y comma y. What is that one? Sigma of y minus y bar into y minus y bar divided by n minus 1. What is that? 50 by 4. What is the value? 12.5. Everyone is okay? Enter calculation. Now this entire calculation, what I have done is called as covariance. Now here, if I take that same thing, what are the numbers I have considered? 1, 1, 2, 3, 4, 5, 16, 7, 9 and 10. These are the numbers, right? Now, what are the numbers I'm having? Okay, for these numbers, I'm applying the covariance. Okay, by considering the two columns. Can you see here? What is this? Selecting the two columns. I have selected the two columns and I'm applying the covariance. Now, can you see first one? What is this? First one is covariance of x comma x. What is the second value? X comma y. What is the third value? Y comma x. Y comma x or x comma y, both are same. What is the fourth value? Y comma y. Total 4 values are there. How you got these 4 values means this is the calculation. 2.5 minus 2.5 minus 2.5, 12.5. 4 values I have shown you here. In the Python code, if you write simply COV, you will get 4 values like this. What is the backend code of that one means? This is the one. It is clear means write. If it is not clear, ask. If it is clear means write now. Write enter calculation in the notes. If it is not clear, please ask. What are the question you are having? Ask. Covariance of x comma x is also called as variance of x. Covariance of y comma y is called as variance of y. What is the variance of x form? What is the variance of x? Open your statistics notes. Go back to the variance, formula of variance. Wherever you have written the variance formula, go back to there. Open once. What is the formula for variance? Sigma of x minus mu divided by whole square divided by n. That is for population. For sample, x sigma of x minus x bar whole square divided by n minus 1. Same thing, na? Same formula, right? Covariance of x comma x, what is the formula? And covariance, variance of x, what is the formula? For the sample. For the sample. Both are same. So covariance of x comma x is also called as variance of x. Covariance of y comma y is called as variance of y. Right, guys? Now, next one is called as correlation. Next one is called as correlation. Now, formula wise, okay. In the interview, if they ask what is covariance, we are going to say the formula. No, that is wrong answer. If they ask what is the formula of covariance, then you have to tell the formula. But they're not asking the what is the formula. They're asking what is the meaning of covariance. Meaning of covariance says that in terms of how much the variance of the x is having with the y. Means, see here, observe this one. If covariance, what are the covariance you have got? Everyone is completed this one, calculation part in the notes. And for you, descriptive statistics, one more task was added in the drive. Open. Earlier, one task was added. Now, one more task was added. Please try to complete that one tomorrow before attending the class. Tomorrow's class will be on the inferential statistics. Tomorrow, we are having the class Saturday. Tomorrow, Saturday, we are having the class. Tomorrow, we are having the class. Saturday, we are having the class. Okay? Why? Why we are having the class tomorrow? That you'll understand tomorrow. But tomorrow we are having the class. Because, sir, why you're not saying today, miss? I also don't know. Naresh IT team has told me that one same answer. I'm also saying for you the same. Sir, keep the tomorrow class, sir, they told. Why, sir, I asked. So tomorrow you'll understand, sir, they told. As it is same thing I'm saying to you also. Same time. Class time will be the same. No difference. Okay. Additional to that, additional bumper offer also is there. What is that offer? Means at 4 o'clock you are having the exam. At 4 p.m. tomorrow at 4 p.m. you are having the exam only on descriptive statistics. Only on descriptive statistics. No need to prepare everything. Exclusively only descriptive statistics. You are having the exam at 4 o'clock. At 7:30 you will have regular class. Regular class. 4 o'clock exam. 4 o'clock exam on descriptive statistics. You have to bring the calculator. Yes or no, miss? Answer is no. You should not bring the calculator. Calculator is not allowed for the exam. Anything you have to do manually only. Sir, decimals comes, miss? Anything. Sir, for decimals 5.4 whole square we have to do, then how we have to, that type of questions will not be asked generally. In the exams or in the certification, simple, the numbers will be given only with the simple. See, earlier I taken the 16, 7, 8, 9, 10. Instead of taking 16, here if I take 14, what happens? Instead of 16, if I take 14, what happens? The average value, instead of getting 9, you'll get 9 point, sorry, instead of getting 10 as the average value, you'll get the 9.8 as the average value. Then what happens means 14.9.8, you'll get 4.2 whole square of this. It will take time. Generally, they'll not give the this type of numbers. So they'll also cross check now. This question can be completed in 2 minutes or not. They'll also cross check, right? Which of the questions can be completed on time manually? Those questions only will be given in the exam. Is the points are clear? So don't bring the calculators. Without using the calculators only, you have to do tomorrow. Okay? Exam is at 4 p.m. and 7:30 regular class based on only descriptive statistics. So in the descriptive statistics, again, anything means entire descriptive statistics from the day 1 to till today, including today's class. Covariance, correlation also included. Don't close the notes. Class was not completed. Still one more topic is the correlation. Wait. Okay. So covariance and correlation. Till this, everything is included. Now, what is covariance? Covariance means variance between two variables. The meaning of covariance means covariance between two variables. Sir, can we calculate the covariance between three variables? Means no. It is a bivariate measure. At a time, two variables only. So for example, I'm having the three variables, A column, B column, C column. Then if I want to calculate the covariance, how I have to calculate means, first you have to calculate the covariance between A and B, A and C, B and C separately. Is the point is clear? Variance between two variables and variation. What are the variation is there? Variation of two variables is called as covariance. Second, covariance value, if covariance is negative, then what is the meaning of that? Means as x increases, y decreases. They are inversely proportional to each other. As x increases, y decreases. And if covariance is positive, then as x increases, y also increases. If covariance is negative, x increases, y decreases. If covariance is positive, x increases, y also increases. Okay. Now, earlier in the example, you got the covariance between them as negative or positive. Sir, 4 we calculated. Now, in that, which one you are asking? See, covariance of x comma x is not called as covariance. It is called as variance. Covariance of y comma y is also called as variance. Covariance of x comma y. Two different variables which you have involved, that one only called as covariance. Single variable, what are the covariance you applied now? That is called as variance. I'm not asking for the variance. I'm asking for the covariance. What is the value you got? Minus 2.5, which is negative. Observe your x values 1, 2, 3, 4, 5. Observe your y values. When compared to first value, it was dropped. Now you take other numbers of your choice. Randomly you write some 5 numbers of your choice in the x. Randomly you write some numbers in the y. Okay, increasing order. As x increases, y increases. Take one example of your choice. In the x, you take any 5 values in the ascending order. Take any 5 values. Now, keep the heading as x and write any 5 values in the ascending order. Any 5 values of your choice. In the ascending order. Similarly, take y values, 5 values of your choice in the ascending order. Any 5. Choice is yours. Any 5 in the ascending order. Okay. Example number 1. You have taken x values in the ascending order, y also in the ascending order. Now, if you calculate the covariance for this one, you will get 100% positive number only. Because as x increases, y also increases, covariance should be positive. Now, example number 2, take another one, another table. Side, one more table you take. Now, x values, you write in the ascending order. Any 5 values of ascending order. Right now. 5 values in the ascending order, x values. 5 values you write in the descending order in the y. In the descending order. Y values you write in the descending order, not in ascending, descending. Now, in this case, what is the covariance you are going to get means negative. If you want, you try. The 2 examples, both of them you try. After the class, that is your assignment. Complete the 2, for the 2 examples, covariances. Calculate the covariances. Okay? And from here, we'll continue in the tomorrow's class. Okay? Correlation will continue in the tomorrow's class. Already 9:10 now. Fine. So tomorrow we'll continue. Right? So complete that. Tomorrow, Saturday, we are having the class. Harita, tomorrow is Bogadi for us. Oh, Harita, if it is difficult miss, you'll get the recording at free of cost. Tomorrow's class, if anyone are missing, because it is extra class now. Okay, if anyone missed tomorrow's class, you will get the recording. I'll share the recording in the Google Classroom at free of cost. Okay, tomorrow's class will be recorded and it will be shared at free of cost in the classroom on Monday morning. Okay, not immediately after the class. Immediately after the class, I will also not receive the recording. So Monday morning, I will receive the recording and I'll upload that. Whenever I receive the recording, I'll upload. Right? Harita, is that clear? If you are unable to attend the class tomorrow, miss, please go through the recording. That is the only thing we can do. Right? Chinmay, tomorrow class is available. Still, any questions? Others you can leave. If no questions, you can leave.